This numerical question, 53.5 gram of aluminium and 22.4 gram of oxygen is given. And as a result, it forms white flame of Al2O3, which reactant is limiting reactant, because when mass of both the reactant are given, then definitely one of them must be consumed first. So we have to find the limiting reactant. Limiting reactant is the reactant that is consumed first, and the mass of the product depends on that reactant because another one is in excess. So this next part of the question is definitely the same. The mass of aluminum oxide produced you are to calculate. So such type of questions can be solved in two ways. So such type of stoichiometric calculations needs to know the molar masses of reactants. So the molar mass of aluminum is its atomic mass that is already given there on the top of the paper. It is 27. And the atomic mass of oxygen is given, that is 16, but its molar mass would be 32. And in the next step, you will need molar mass of Al2O3, aluminum oxide. So you can calculate molar mass here. Molar mass. Molar mass means mass of 1 mole of a substance. So molar mass of aluminum oxide. How can you calculate? There are 2 aluminum. So 2 multiplied by 27 plus 3 oxygen. So 3 multiplied by 16. So when you calculate it, you will get 102 as it is molar mass. So its unit is gram per mole. Now the main calculation or the solution of the numerical is start by rewriting the chemical equation. It is easier way. So for the solution, we have written this equation again. So see what is given here. 54 moles of aluminum are given, and 3 moles of oxygen are given from the chemical equation, balanced chemical equation. So 4 mole of aluminum combines with 3 mole of oxygen to produce 2 mole of aluminum oxide. So first we will uh, first we will find the limiting reactant by calculating the number of moles of aluminum and oxygen. So how many moles of aluminum are there? So calculate the moles first. Moles of aluminum is equal to given mass. Given mass is 53.5 divided by 27. So you should calculate it. It is 1.98 mole. And also calculate the moles of oxygen. It is 22.5, 22.4 is given divided by molar mass, that is 32, and its number of moles are 0.467 mole. So these are the given number of moles. We have just converted the given mass into number of moles. Okay, so now we will see how much aluminum is required and how much oxygen is required. So we can start on either way. We can start with aluminum to calculate the required mass of oxygen, or we can calculate the we can start with oxygen to calculate the mass of aluminum. So here I'm doing both of these, but in exam you are to do only one of them. So from the balanced chemical equation, you can see here 4 mole of aluminum requires 3 moles of oxygen. So for 1 mole, it's better to write 4 mole here. So 1 mole aluminum requires 3 upon 4 mole of oxygen. And we are given 1.98 mole. So 1.98 mole aluminum requires 3 upon 4 into 1.98 mole of oxygen. So calculate it, use your calculator. So here we found it is 1.485 moles. And how many moles are given here? I think I have calculated this incorrectly. Let me correct the number of moles of oxygen. Yes, it is wrong. It is just 0.7 moles. So 0.7 mole of oxygen are given and 1.98 moles of aluminum are given. So if you see here, one for 1.98 mole, we need 1.485 mole. So we can find here that oxygen is given in the lesser quantity as compared to the required one. So oxygen is the limiting reactant because its amount given uh, better to write amount as well, and this given amount is 0.7 mole is lesser than the required amount, and the required amount we have calculated here, it is 1.485 mole. So in this way we have found the limiting reactant, and here you can see oxygen is the limiting reactant. Oxygen is the limiting reactant. So and see the another way now. In another way, you start with oxygen. So see how much oxygen is given. From the calculation, you can see 3 mole oxygen requires 4 mole aluminum. So how much aluminum is required for 1 mole? So 1 mole oxygen requires Sorry, it should be 3, 4, 4 upon 3 mole aluminum. And how much oxygen is given here? It is so 0.7 mole oxygen requires 4 upon 3 times 0.7 mole aluminum. So now you can calculate using your calculator. So from this calculation, you can see we require its amount is calculated, that is 0.933 mole. And how much aluminum is given? It is 1.98, and we require only 0.933. So it means aluminum is in excess. So aluminum is in excess while oxygen is the limiting reactant. Definitely one of them is in excess, so other would be the limiting reactant. So in this way, we have calculated we have determined what is the limiting reactant in the given numerical. So oxygen is the limiting reactant. You can use either of these two ways. Next, or the main part of the numerical, that you have to find mass of the aluminum produced. So we have found the limiting reactant. So further calculation will be carried out by using the amount of oxygen or the number of moles of oxygen that we have already calculated. It is 0.7 mole. So again, we need the chemical equation for further calculation. So from the chemical equation, 3 moles of oxygen produces 2 moles of aluminum oxide. So we will start our calculation from there, that 3 mole oxygen produces 2 mole aluminum oxide. So 1 mole oxygen produces 2 upon 3 mole aluminum oxide, and we are given 0.7 mole oxygen, so it will produce 2 upon 3 times 0.7 mole of aluminum oxide. So calculate using your calculator. Okay, so meanwhile you have also calculated, hopefully, and what I calculated is 0.467 mole. So now you have the moles of aluminum oxide, Al2O3. You are to calculate mass of aluminum oxide. That was required in our question, that mass of aluminum oxide. So for calculating mass, multiply number of moles with molar mass. So number of moles are 0.467, and the molar mass of aluminum oxide we have already calculated is 102. So now calculate it and see what is the mass? So the mass that we have calculated here is 47 point 1 minute. I think I have made a mistake. No, it is correct. 47.67 47.634 gram. So this amount, this mass of aluminum oxide is produced. So you can write your answer that limiting reactant is O2 and the mass of aluminum oxide is 47.634 gram. Now see in this numerical what are the steps. Now see what were the steps here. First of all, we have calculated number of moles of given reactants. And after calculating number of moles, we calculate or determined, we calculated or determined the limiting reactant. So there are two ways of determining limiting reactant. You can use either of these two ways. So either use this calculation or this. Don't go with with both of these. Anyone is enough. And then you calculated moles of aluminum oxide produced from the given amount or the given moles of the limiting reactant, and then mass of the aluminum oxide. And finally, we can write the answer separately. So these are the results. So we have seen the solution of this solution of this numerical by method 1, where we first calculate the molar mass, then we calculate the number of moles of the reactants, and then we found the limiting reactant. And after finding the limiting reactant, we perform further calculation for calculating the yield or the given mass of the product. Not the given, sorry. From the given mass of limiting reactant, we calculate the maximum amount of product that can be obtained by the reaction. But we have another method for solving such question. Although in my view, only the method 1 is the correct, only the method 1 should be the choice. But some teachers, instructors also calculate uh, such also solve this numerical in some other ways. For example, see in method 2, these are the same steps. There is no change, but change is here. Instead of finding limiting reactant, they directly calculate the number of moles of the product from the given amount of both of the reactant. So we will remove this step here. Next step is first calculate the amount of aluminum oxide produced by one of the reactant, then another one. So we have already calculated number of moles of aluminum oxide and the mass of the aluminum oxide produced by starting from oxygen. So here we have calculated the moles of oxygen from moles of aluminum oxide from oxygen, and the another reactant is aluminum. So if we calculate the mass from the mass and the moles from the given amount of aluminum, so we will perform almost the similar steps. Now moles of Al2O3 from aluminum. So what to do? Acha, one more thing. So now this would not be the result, although we will get the same result, but we can't write it here. Okay. So from the given equation, you can understand that 4 moles of aluminum produces 2 moles of aluminum oxide. So now see, 4 moles of aluminum produces 2 mole Al2O3. You can see from the balanced chemical equation. So for 1 mole of aluminum, it would be 2 upon 4 mole aluminum oxide. So the given mole of aluminum is 1.98. See here, 1.98. So 1.98 mole aluminum produces this 2 upon 4 becomes 1 upon 2. 2 on the 2 to the 4, or you can put it as it is. It's up to you. And it is 1.98. So finally, you will see it would be 0.99 mole of aluminum oxide. Now see, from the mole, it is very clear that as oxygen is producing less number of moles of aluminum oxide, that's why as compared to the number of moles produced by aluminum, so oxygen would be the limiting reactant. So we can see here oxygen produces only less number of moles less number of moles. How much are there? 0.467 as compared to used by aluminum, that is 0.99 mole. So Oxygen is the limiting reactant. So we should put this amount, and you can see I have not calculated the mass here because it is very clear from the number of moles. So we should do this calculation afterward. So the mass of aluminum oxide will be calculated from oxygen. The result would be number one, what is the limiting reactant? Limiting reactant is O2, and the mass of Al2O3 produced would be 47.634. So actually what we are doing here, we first calculate the number of moles produced from both of the reactants, and which one produces lesser number of moles, we go for further calculation by using that number of moles. So as here, oxygen produces only 0.47467 moles, while aluminum produces more moles. So definitely it will consume first. It would be the limiting reactant, and we calculate the mass from these number of moles, and we will ignore these number of moles of aluminum oxide produced from the aluminum.